This video is for advanced users, showcasing customized knowledge representation with Prolog programming language for advanced system development. To enable this, go to Menu, User Profile and select Advanced Mode, allowing the use of both natural language and Prolog for defining decision-making policies. Now, we'll create an automated seller agent that adjusts pricing based on context for an online retailer. This simple use case can be expanded for business needs. We will click on the Edit Project icon to access the dashboard. We will build decision arguments by using options as conclusions and scenarios as supporting evidence. First, we define the options. The first option is sell at regular price. The second option is sell at promotional price. The third option is I cannot sell this product for the situations where the stock is not sufficient to meet demand. Next, we create first scenario. The stock exceeds the requested quantity. We recall that a scenario consists of essential elements that serve as reasons to support and enable a given option, and that an element is a piece of knowledge, or fact, that we know is valid, or true, and must be provided as input by the user. We will link the first scenario to two options since in our case, if the stock exceeds the requested quantity, the product can be sold at either a regular or promotional price. Now we create the second scenario. The quantity exceeds the stock. We recall that two options are in conflict when they cannot both be valid simultaneously, requiring a decision maker to choose between them. We link this second scenario to the option I cannot sell this product because the sale cannot proceed if there is insufficient stock. Regarding the first scenario, we have a conflict as a product cannot be sold at both promotional and regular price simultaneously. To make this decision, we have the process called conflict resolution. RAISON detects conflicts and aids refine the decision-making process. We select primary choice because according to our use case, in this scenario, our default preference is to sell at regular price. We click on Sell at regular price. RAISON then asks to provide reasons for selling at promotional price. We answer yes, because our use case defines two specific conditions, or reasons, for this purpose. The first condition, or reason, is that the buyer is a regular customer. We type regular customer. No additional constraints affect this decision. We confirm the policy and proceed by selecting No, ending the exploration of this solution. Once a solution is explored, RAISON retraces its steps to consider alternative solutions. So, we are back at the stage where we defined the first specific condition for selling at a promotional price. We will answer yes in order to implement our second policy. The requested quantity is greater than 3 products. We type the requested quantity is greater than 3 products. RAISON asks now if we want to add elements to change the decision to regular price. In our use case, the sales period is a factor, so we answer yes and type sales period. By regular price in sales period, we refer to the prices set by the business policy for all customers during this period for each product. Now, RAISON asks if we want to add more information to refine the decision. We answer no, ending the exploration of this solution, since no further elements influence the decision in our case. Here we select no again since the sales period is the only relevant factor. RAISON then returns to the stage where promotional pricing conditions are defined, and we confirm no for the same reason. Conflict resolution process is complete and RAISON confirms. Now, by clicking on Decision Policy, we can review and validate what we have taught our seller agent. RAISON provides filters based on options or scenarios. Now let's go back to the initial scenarios and options. By clicking on Manage Elements, we can see all scenario elements created since the beginning of the development. Let's click on the element of the first scenario. We can see the basic user development mode version. We use the toggle button, available only in advanced mode, to switch to Prologue. RAISON has already generated an automated representation. We customize the representation to allow users to input stock and quantity values. RAISON selects the input field by default. We then uncheck and delete it. We can now customize the representation. We note that neck operator is not allowed to use. As we type text separated by commas, RAISON generates sub-elements. Developers can specify whether they are input data from a user, database, an application using our API, or not. Dividing scenarios into sub-elements enhances reusability across scenarios. We define predicate stock to represent the stock level. Now, let's define the predicate rec_quantity to represent the requested quantity and add the constraint stock greater than equals quantity, indicating that the stock exceeds the requested quantity. We navigate to first sub-element and consider it as input data. In a real-world application, this value would be retrieved from a database. However, for our demonstration, we will consider this value to be provided by the user, and write available stock as the query. Now, moving on to the second element. This is also input data because it requires user input. We will specify the message, quantity requested. Let's now proceed to the third sub-element. This is not input data since it represents information related to the agent's knowledge. So we uncheck the field. We will write that the stock exceeds the quantity. We will apply the same process to the other scenario reusing the stock and rec_quantity predicates. We simply need to adjust the constraint, uncheck the input data field, and delete the representation suggested by RAISON. Although not visible, we can choose the previous custom representation. We can now proceed with the only required modification. RAISON preserves the two common sub-elements shared with the previous scenario, preventing any modifications to them. We modify the constraint by typing stock less than quantity, and thus the only sub-element that can be modified is the one related to the constraint. Since it is not input data, we uncheck and we will define it quantity exceeds stock. Now, moving on to the final representation that requires modification. This is not input data. We uncheck the field and delete RAISON current representation. We will use the variable quantity from the predicate rec_quantity and write quantity greater than 3. With this, we have completed our customized Prologue representation. We switch back to natural language and we find the natural language representation of all the sub-elements. Clicking Decision Policy shows decision rules in natural language, while switching to Prologue reveals the customized representation. This enables collaboration, with basic users defining policies in natural language and advanced users translating them in Prologue. Now return to initial scenarios and options to customize the automated representation of option names proposed by RAISON. We switch to Prologue again. This time, we include the stock and quantity variables, used in the defined predicates to represent available stock and requested quantity, in the options names. We switch back to natural language, navigate to the menu, and click Run. RAISON instantly generates the code and deploys the developed system. We are now ready to use the seller agent we developed. The input data fields are available. We will start by entering values for the stock and the requested quantity. We enter 30 for the stock and 2 for the quantity and we click Run. The seller agent decides to sell at regular price. No, we add regular customer. The seller agent decides to sell at promotional price. We now change the quantity to 5. The seller agent decides to sell at promotional price. However, if we add sales period, it changes its decision to sell at the regular price. Let's now change the value of requested quantity to 40. We can see that seller agent announces that it cannot sell this product. This concludes the video. Thank you for watching.